Hello friends, uh, today we are going to study chapter 3rd of environmental engineering of civil engineering subjects. This is the third chapter of environmental engineering, that is quality of water. Quality of water. So this is very important chapter, very important chapter for GATE exam and IES also. Okay, so every year almost 2 to 4 marks question comes to GATE from this chapter. 2 marks or 2 to 4 marks generally comes, so it is very important for GATE and IES also. Quality of water. So we are starting quality of water. So water quality is tested once before treatment and once after treatment. Means if raw water means what? Water is not pure. Water is not pure. So tested raw water it is tested once before treatment. Means we test raw water and we get to know how much impurity dissolved or is there in raw water. How much impurity to know, we test it. Then treatment during treatment, so this is water treatment. Water is getting treated, raw water is getting treated, and after treatment impurities gets extracted from raw water. Okay, then after that wholesome water. After treatment we get wholesome water, means water which we can drink. Wholesome water having no impurities, means we can drink this water. Then after treatment this water also get tested. Water test. So why we test wholesome water? Because we want to know the impurities level in this. So is it as per standards? So is it as per standards, means how much bacteria left or how much uh, color, taste, odor, these things, means is it as per the standard or not. That's why we test this wholesome water. Okay, so before treatment water quality is tested. Before treatment water quality is tested to know the extent of impurities in water, means how much impurity is there in water. Which water? Raw water. In raw water, and based on this the extent of treatment we give to the water, means how much impurity in raw water, that much treatment we give to that raw water. Okay, then after that what? After treatment, means water gets treated, then after treatment once again water quality is tested to ensure how far treated water meeting the standards, stated standards. There are some standards the drinking water should have, means what color, taste, odor, turbidity and microorganism, these things should be as per the standard. So this thing we test again once again to know the how much it is pure. Okay, then we talk about impurities in water. Now we'll talk about impurities in water. So impurities broadly classified based on size of impurities, nature of impurities, based on size, of impurities, based on nature of impurities, based on state of matter. Okay, so now we'll talk about size of impurities. Means impurities in water broadly classified based on size of impurities. So based on impurities, suspended impurities means particles are suspended in water. Then colloidal impurities, in colloidal form impurities are present in water. Then dissolved impurities which are dissolved in water. So suspended impurities size of the particle varies from 10 to the power minus 1 to 10 to the power minus 3 mm. Okay, and in micrometer, 100 micrometer to 1 micrometer. Okay, and these are macro macro impurities. So suspended impurities are what? Micro impurities, and these impurities are visible from our naked eye. Okay, we can see these impurities. Then after that comes colloidal impurities. So particle size of colloidal impurities varies from 10 to the power minus 3 to 10 to the power minus 6 mm. And in micrometer, 1 micrometer to 1 10 to the power minus 3 micrometer, mu m, micrometer. So these are micro micro impurities. We cannot see these impurities from our naked eyes. Okay, then dissolved impurities which are dissolved in water. So this dissolved impurity size varies from 10 to the power minus 6 to 10 to the power minus 8 mm. In micrometer, 10 to the power minus 3 to 10 to the power minus 5 micrometer. Okay, so no one note point is here, like if size is less than 10 to the power minus 1 mm, these particles do not travel with water, so these are not significant. Do not travel with water, these particles, so these are not significant for us. Whereas sizes greater than 10 to the power minus 8 mm of particle generally do not exist, means not existing till today. Means this size of particle greater than 10 to the power minus 8 mm size particle do not exist till now. We didn't found. So, and again, now we will talk about nature of impurities. So first one is organic impurities, second one is inorganic impurities. Organic impurities highly objectionable since means because they promote the growth of microorganism. Inorganic due to organic impurities microorganism grow in that water. Means organic matter is food of microorganisms, so they eat and they grow. Okay, so it is highly objectionable. Organic matter should not be present in water. Okay, then inorganic impurities. Inorganic impurities naturally present inorganic impurities. These are some are in inorganic impurities. These are some are naturally present inorganic impurities, and this is good for it. Okay, this is A, this is B, and some are human induced inorganic impurities. Human induced, so this is toxic, not good for health. Okay, then based on state of matter, based on physical state, chemical and biological state, we further subdivide the impurities. Okay, so this is not page number 27. Where is 28? Page number 28 here. So this is page number 28. Then a physical water quality. Based on physical state, it defines those characteristics of water which responds to sense of sight. Physical, these are physical quality of water. Sight, how it looks, touch, feel and smell and taste. So these are the physical quality of water. Okay, so based on this sight, touch, feel, smell and taste, we further subdivide the impurities. And then after that, the following parameter define the physical water quality. So first one is temperature, second color, turbidity, how much water gets passed through the raw water, it's called turbidity. How much resistance it offered to pass the light through it. Turbidity, odor and taste, odor, smell and taste. So now, based on temperature, it is the measure of heat energy. Temperature is what? Measure of heat energy. Temperature is measure of heat energy. Okay, so if temperature increases of the raw water, means water which is not pure, and the temperature increases, then the growth of microorganism also increases. Means it favors the growth of microorganism if water temperature increases. So it is directly proportional to the growth of microorganism. This is important. Growth of microorganism is directly proportional to temperature. Okay, growth of microorganism is directly proportional to temperature. Whereas solubility, how much gases are soluble in water, or how much gases are soluble in water, is inversely proportional to temperature. If temperature decreases, gas solubility increases. Means in cold water more gases will be present, whereas in hot water less gases will be present. Okay, so gases solubility is inversely proportional to temperature. You think, in boiling water less gases will be present, means after gaining energy from fire, gases vaporizes, or means gases escape from the water. Whereas in cold in cold water, gas is entrapped into water, and means some kind of condensation due to less energy, due to coldness of water. So solubility of gases is inversely proportional to temperature. Okay. Then chemical reaction. Then chemical reaction is also directly proportional to temperature. How much chemical reaction is going to happen in raw water or water which is not pure is also directly proportional to temperature. Means as temperature increases, chemical reaction increases in raw water. Chemical reaction. Okay, this is as obvious. And talking about viscosity, viscosity viscosity is again inversely proportional to temperature. Inversely proportional to temperature. Viscosity is what means how much thick a fluid is, means like honey and water, which one is more viscous? Honey is more viscous. Means we any like any coin or ball cannot uh, propagate easily in honey due to thickness of honey. Okay, so it is more viscous, whereas in water it is less viscous. So any ball easily travel in water, so it is less viscous. So viscosity is what? Viscosity is viscosity viscosity is what? Inversely proportional to temperature. Viscosity is inversely proportional to temperature. I am not means promoting any website or any notes or anything. This material just to teach you, not for any promotion. So these are not for any promotion. I am not promoting any classes, notes or any online shop. Okay, you can contact to them, no problem. I don't have any problem to get the notes of IES and various examination. You can contact to them. I don't have any problem. I'm just teaching you from these notes. Okay, so drinking water standard. So drinking water standard means water drinking water temperature should vary from 10 degree to 20 degree. This is the standard. We test wholesome water after treatment, na wholesome water. So this is the standard. Means wholesome water should have 10 to 20 degree temperature. This is the first standard we got to know. So drinking water temperature should be in between 10 to 20 degree centigrade. Okay, and one note point is here. If oxygen is less in water, if oxygen is less if oxygen is less in water, oxygen is less in water, this is less potability. Means less potability is less, means less oxygen in water, less potability in water. And temperature is greater than 10 temperature, if temperature is less than 10 degree centigrade, means temperature decreases, viscosity increases. Okay, so if viscosity increases, it is difficult to supply water. Means cold water we can cold water, as obvious, it is difficult to supply. Okay, due to viscosity increases due to coldness. Okay, then now after through the colorness, then we talked about temperature. Now we'll talk about what? We'll talk about color. We talked about temperature. Now we'll talk about color of the water. So water through to be colorless, means drinking water should be colorless in nature. So there are two types of color noticed in water, means there are two types of color noticed in water. First one is apparent color. This apparent color is due to suspended particle. When suspended particle gets settled, then this apparent color gets lost. Okay, so suspend due to apparent color is due to what? Due to suspended particle in water cause apparent color. Okay, then true color is real color of water, means true color is caused by dissolved substances, means which are dissolved, like sugar is dissolved in water. Okay, so dissolved due to dissolved substances. These dissolved substances do not get settled with time, so this is permanent, almost permanent. So true color is due to dissolved substances in matter. Okay, color in water is measured by using device called tintometer. This is important. Tintometer is what? Tintometer and measured by Burgess scale or platinum scale. Burgess scale or platinum scale. Color is measured in color in water is measured by using a device called tintometer. This is very important. Remember this: tintometer color, and measured on Burgess scale. And scale is what? Measured on Burgess scale or platinum scale. Okay, try to remember this. Drinking water temperature should be in between 10 degree to 20 degree. This is one standard. Another standard is what? Means color is measured in color is measured by the device. This device? Tintometer. This is important. And the scale is Burgess scale or platinum scale. Measured on Burgess scale or platinum scale. Okay, this is very important. And it is expressed wait, this is 20, this is 29. Okay, now, and it is this color is expressed, and this expressed in terms of TCU. TCU is what? True color unit. TCU is true color unit. TCU. Remember, tintometer is device to measure color, and scale is Burgess scale or platinum scale, and unit is what? It is measured in terms of TCU. TCU is what? True color unit. Okay, now define 1 TCU. This is again important. Define TCU. So you take 1 mg platinum. Okay, means 1 mg of platinum as a dicroplatinate. Okay, ion. 1 milligram of platinum as what? As dicroplatinate ion. Remember this: chloroplatinate ion and platinum. 1 mg. How much? 1 mg in 1 liter of water, distilled water. 1 liter of distilled water. Remember this: 1 TCU. What is 1 TCU? 1 milligram of platinum as a chloroplatinate ion mixed in 1 liter of distilled water. Then the color produced is called what? 1 TCU. 1 TCU what? Means true color unit. I am repeating once again: 1 milligram of platinum in form of chloroplatinate ion mixed in 1 liter of water, 1 liter of distilled water. Then the color is produced is taken as 1 TCU, 1 true color unit. This is also known as Hazen unit. So device is tintometer. Again repeating so that you remember easily. Device is tintometer. Scale is Burgess scale or platinum scale. In terms of, it is measured in terms of TCU, true color unit, and true color unit TCU is also known as Hazen scale. Hazen scale. These things are important. So try to remember these things. Okay. So standard, again the color standard of drinking water should be in between 5 to 2 CU. CU is what? Color unit. So remember this again. Drinking water temperature should be in between 10 to 20 degrees centigrade. Drinking water temperature. Okay, should be 10 to 20 degrees centigrade. And color should be in between 5 to 20 CU. CU color unit. So drinking water, this is another standard of water. Drinking water. So color should be in between 5 to 20 color unit. Okay. Okay. So 5 color unit, 5 CU is minimum permissible. Minimum permissible limit. Okay. 5 color 5 CU is minimum permissible limit of the color. Minimum, it should not be less than 5 CU and it should not be greater than 20 CU. Maximum limit is what? Maximum permissible limit of color is 20 CU. Okay. Okay. So that's it. Now we'll talk about turbidity. So what is turbidity? Turbidity is the measure of resistance offered by particles. This is the impurity particles. So it offers resistance to pass the light. Light gets deflected by these particles, impurity particles. So it offers resistance. So turbidity is the measure of resistance offered by the particles present in water to pass passage of light through it. Okay. So it offers resistance, means this impurity particle offer resistance to means they do not allow to pass the light easily. Because of what? Because of these impurity particles. So turbidity is the measure of resistance offered by particles. Turbidity is measure of resistance offered by particles present in water to passage of light through water. Okay, clear? Now opaqueness of water is known as turbidity. Opaqueness of water is known as turbidity. Okay. Now turbidity in water is caused by what? Due to suspended particle, which are suspended particles, and by colloidal particles. So cause of the turbidity is due to suspended, due to colloidal. These two are the cause to turbidity in water. Okay. Now turbidity is surface phenomena. Now we'll see this how. So turbidity is directly proportional to resistance of light. As the resistance of light increases in water, means what? Means particle increases, and this particle, impurity particle, increases resistance of light. Resistance to pass through this water increases, so turbidity increases. So turbidity is directly proportional to resistance to light. Okay, clear? Now again, turbidity is directly proportional to surface area of particle. Okay, see, means how much area of particle. Okay. So this as surface area of particle increases, so turbidity is increases. Surface area increases, more area is present to resist the light, so turbidity increases. Simple. More area, more resistance to pass through the water, so more area, more turbidity. Okay. Now, and size is how size is related to turbidity. Now, turbidity is inversely proportional to the size of particles. Turbidity is inversely proportional to the size of the particle. This particle is bigger in size, this particle is smaller in size. So as size increases, turbidity decreases. Okay. As size of the particle decreases, turbidity increases. Means a small size particle will reflect more, will offer greater resistance. A smaller size of particle to pass the light, so more resistance in smaller size of particle, whereas in bigger size of particle it offers less resistance, less resistance. So turbidity is inversely proportional to the size of the particle. Now remember this is very important. Remember this, try to remember this, make short notes of this. Okay. So this is important, try to remember this, important. Okay. Now, turbidity in water is measured on silica scale. Turbidity on water is measured on silica scale. Silica scale. So this line is very important. Silica scale, turbidity. Silica scale is used for turbidity. Silica scale, turbidity. Turbidity. Silica scale. Silica, turbidity. Silica, turbidity. Okay. And Burgess scale for what? Burgess scale for color unit. You heard of Berger paint? Berger paint. Berger paint is color. Berger, Burgess. Similar. So remember, this is a trick to remember. Burgess scale for color. Berger paint. Burgess unit. Burgess scale for color. Easy. Now, turbidity. Silica scale for what? Silica. Silica is like in this way we can easily remember silica or sand almost. So silica is very quantity of silica is very high in sand. So silica, sand means what? Sand particles, silica. So sand particles, these are particles, so offer resistance to pass light in water. So silica is for sand and silica is a scale of turbidity. Simple. Try to remember in this way. Silica scale is for turbidity, and in terms of turbidity unit, TU, turbidity unit TU. Now define one TU. Important. This is important. One more question will come from this. Okay. So what now? What define one turbidity unit? So when 1 milligram of fine divided silica mixed, fine divided silica fine divided silica means like this is not exact to say like sand, how much sand. So this is just I'm telling you for to remember, how to remember. This is not that sand, means it is proper definition is 1 milligram of fine divided silica mixed in liter 1 liter of distilled water, then the turbidity is produced is taken as 1 tu, 1 turbidity standard, 1 standard turbidity unit, or jtu. Jackson turbidity unit, Jackson turbidity unit, tu or jtu or tu, turbidity unit, Jackson turbidity unit. So 1 tu is what for silica, fine divided silica, fine divided means crust, fine divided silica mixed in water, then the amount of turbidity is produced, then that is taken as one standard tu, turbidity unit. Okay, so we define this. Now comes to 30, page 30. No, page 30. Now turbidity in water is measured by which work on principle of light absorption and light scattering. Light absorption and light scattering. This particle, how much light get absorbed during passing to water, and how much light is scattered, how much light is scattered in this principle we measure turbidity. So turbidity in water is measured by devices, and these devices works on principle of light absorption, light scattering. So these devices works on principle of light absorption and light scattering. Okay, now devices which work on principle of light absorption are Jackson turbidity rod, JTR, Jackson turbidity rod. So first one is Jackson turbidity rod, Jackson turbidity meter. These are the devices. Bayes meter, Hillige meter. These are the devices. So which works on the light absorption and light scattering principle. So one Jackson turbidity rod is what for field measurement of turbidity. On field we measured by Jackson turbidity rod. Okay. Second one, Jackson turbidity meter, measured only high turbidity in water, cannot measure turbidity less than 25 Jackson turbidity in JTU. So it is it only works in high turbidity range, and it cannot measure turbidity less than 25 JTU. We're talking about Bayes meter. Bayes meter measure how low turbidity in water, means low turbidity measured by Bayes meter, and that turbidity ranges from 0 to 5 JTU. Then talk about Hillige meter, measure moderate turbidity in water. Moderate turbidity means 10 to 50 JTU. So these are outdated. These devices are outdated devices. Outdated. Obsolete device. Obsolete means outdated. Outdated. This is old devices. Means we use these days nephelometer. So device which works on principle of light scattering. So these devices works on principle of light absorption. These devices works on principle of light absorption, and nephelometer works on principle of light scattering. So device which works on principle of light scattering is nephelometer. Nephelometer is digital electronic device. So it is a digital electronic device. The one means you might have done your experiment in your college engineering, that you might have seen that nephelometer. So try to remember those days. So now talking about nephelometer. Nephelometer, it measures turbidity instantly, very quickly, instantly, and very accurately. So nephelometer is fast and accurate. Nephelometer is fast and accurate. Okay, and measure very low turbidity. Very low turbidity also measured by very less turbidity, means very low turbidity in water. So it measures very low turbidity in water with high degree of precision, means it is very precise, very accurate, means very closely uh, to accurate value it measures the turbidity, and also measure high turbidity in water by calibrating the devices. Okay, high and also measure high turbidity in water by calibrating the devices, and it measures turbidity in terms of NTU. Turbidity in nephelometer, NTU. NTU means nephelometric turbidity unit. NTU in nephelometric turbidity unit. So define one NTU again. 1 milligram, take 1 milligram of formazine polymer. So these are important. Formazine polymer in nephelometer. Formazine polymer in nephelometer. So important. Try to remember these things. 1 milligram of formazine polymer mixed in 1 liter of distilled water. Then the turbidity produced is taken as 1 NTU. Formazine polymer 1 gram. Formazine polymer 1 gram in 1 liter of distilled water. Then the turbidity produced is taken as 1 NTU. Okay. Now try to remember this definition and that formazine polymer important. Now nephelometer always measure amount of light scattered right angle 90 degree right angle to the incident light right angle. This is impurity light coming, reflected 90 degree. Okay, so nephelometer always measures amount of light, how much amount of light scattered at right angle to the incident light, incoming light. Okay, so these things. Now so this is the diagram, and this is diagram for nephelometer working principle. So light is coming, light is coming, and it get passed and concentrated on the water. This is raw water. This is raw water, means water having impurities. Impurities particle, water sample. This is water sample. Okay, so this coming get light get deflected in 90 degree, 90 degree, 90 degree, 90 degree. Okay, and this deflected light gets detected by photometer. 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 So we measure how much light get deflected through nephelometer, means these are nephelometer. So this is raw water, this is raw water, and these are nephelometer. Blue, this is blue nephelometer. These are nephelometer, blue one. Green one is raw water, and these are the coming light source, and these lens, this light get concentrated on raw water. So this is the diagram. This is the principle, how working principle, how that nephelometer work. Okay, to try to remember. Photometer is used to detect how much water get deflected. Okay, now so standard of turbidity in terms of NTU 5 to 10. Remember, drinking water standards 5 to 10 NTU. Turbidity should be in range of 5 to 10 NTU, nephelometric turbidity unit. Important. Try to remember this. Now, fourth point. Water through to be odorless and colorless. Means drinking water should be smell. No smell is there, and no taste is there. So water should not have smell, odorless. Water should not have any taste, tasteless. So this is drinking water should be odorless or tasteless. So odor in water is measured by device known as osmoscope. Odor, o, odor, then o, osmo. So o is common. So try to remember in this way. Odor, osmoscope. O, odor, osmoscope. Okay. Odor, osmoscope. And water odor is in water is measured by the device known as osmoscope and expressed in terms of ton, ton. So ton, threshold odor number, ton ton for odor. It is measured in terms of ton, ton. So ton is a dilution ratio at which odor is just detectable. Ton is dilution ratio. This is ton formula. We'll talk about. Ton is dilution ratio at which odor is just detectable. We can detect. So ton is what? Ton. This formula is very important. So many times we get question from this formula on basis of this formula. Ton. Ton in ton is A plus B by A. So A is what? A is volume of water sample tested. Water sample. A is water sample. Sample means that impurity water. Sample of that impurity water. So A is volume of water sample tested in ml. Less water measured in terms of ml. So now what is B? B is distilled water, volume of distilled water used in dilution of that impure water. Okay. B is volume of distilled water used in distillation, and this measured in also, it should be also in ml. So now these two volumes should be, sum of these two volumes should be in 200 ml. Okay, sum of sample water and this diluted water, these two sum have 200 ml. Okay, so capacity of osmoscope is 200 ml. Important again, remember A plus B should be 200 ml. No test to find the taste in water, but sense of smell and taste are closely associated with each other. There is no test to find the this is no test to find the taste in water. Okay, टेस्ट के लिए कोई भी टेस्ट नहीं है. टेस्ट मतलब स्वाद के लिए कोई भी टेस्ट नहीं है. ओके, नो टेस्ट. So no test to find the taste in water, but senses of smell. How smelling, you're smelling that water. Sense of smell and taste are closely associated with each other. Means smell and taste related to each other. Okay. Now, if water smell bad, smell of water is not good, foul smell coming from water, then taste, it also tastes bad. Okay. Dirty water taste is also bad, smell is also bad, but taste is expressed in terms of FTN, flavored threshold number. FTN, flavored threshold number. Flavor, FTN, flavored threshold number. So formula is again same from ton and FTN, that is A plus B by A. Small A is having small quantity generally, so less a small quantity. Drinking water standard, again standard should be 10 should be less than 3. This is not 13, this 10 should be less than 3 or 13, confusion is there. Okay, you go to Google and check 10 standard should be what, I think 3 or 13. Okay, so that's it in this tutorial. We'll continue this quality of water chapter. So we'll continue this, we'll meet in next video. Thank you, and try to revise this and make short notes of important points. This will be very helpful just before your examination. You cannot go through whole notes in one day, so you need some material to revise quickly. So try to make short notes on one copy, separate copy. Okay, so we're going to meet in next